All right, let's talk VFDs. As usual, when we are discussing something like this, as we talked about with our PLC programming and our intro lecture on PLCs, it's always a good idea to check the instruction manual. Now today we are playing with an Allen Bradley Powerflex 4. We got it here on the lab board. Okay, and the first question I pose to you is, can we run a three-phase motor on 120 volt AC? Thoughts? Hell yeah, I like that. It's looking good. Looking good. Looking good. Looking good. Typically, straightforward ways, not really. But with our variable frequency drive, we can absolutely, since we are basically gaslighting our motor into thinking it's getting AC, we can absolutely take incoming 120 volt and run a three-phase motor with 120 volt. Okay, no problem. Should be an easy task to accomplish. You just have to make sure you have a frequency drive that is rated for the scenario. This Allen Bradley Powerflex here happens to be 120 in, 208 three-phase out. Okay, is there a simple way to do it outside of this? There are techniques. Okay. Exactly. The switches inside, those IGBTs inside of the Powerflex drive, are going to emulate, right? Using pulse width modulation, we are going to create a sine wave that is three-phase. So we are going to do all of that with the power of our little magic box, okay? So all I'm going to do is I've got a conveyor belt motor from the factory. It's just a little guide. This is 1/10 horsepower. We use these on all the conveyor belts, 208 volt, three-phase. Okay, so we are just going to hook that up right to those three leads on the top. I got them pre-wagoed out. I'm not going to hook up the ground because why would I do that? So I'm going to hook up these leads coming out of the drive real quick right to those. Okay, so let me get that. Let me get that. And let me get that one before I turn anything on. Cool. We have done the first step of the mission, is that's getting this thing kind of hooked up. So again, what you're really going to want to do is refer to your instruction manual. Now, just like any good digital electronic instruction manual, this thing's pretty long, 109 pages it says. Okay, and that doesn't include the index that goes on for a while. Lots of great information in here. If you have one, you probably want to look through it, especially if you're doing some fine tuning or trying to troubleshoot something or set up something complex. We're not going to do anything incredibly complex tonight. We're just going to go through some basic functions of this. So for that, Allen Bradley was nice enough to grace us with a quick start guide for the Powerflex 4. So this is a much more condensed version. But as usual, you're going to go through, you're going to see some mounting instructions as we talked about during our lecture portion. These drives are going to generate a significant amount of heat. So we want to make sure that we are following their spacing considerations and depending on our enclosure ratings in the environments, we're going to want to watch our mounting options, make sure we have adequate airflow into the enclosure, so we don't overheat this drive. Heat kills. Heat kills microelectronics, and it will absolutely toast this thing. Okay, so we've got all of those considerations. We've got some informations on specs, fuses, and circuit breakers that you should be running with these, which is a fantastic piece of data. I'm not going to go into that in detail. And then we have power wiring in for our specific application tonight. We are doing that single phase input. So we will just be going to R and S on line 1 and line 2. I'll show you that in a second. When you do have a three-phase unit with three-phase power in, you will run R, S, and T. Those are your incoming power lines. And a lot of times they will be labeled L1, L2, L3 as well, but not always. Depending on the manufacturer and the make, you might only have them listed as R, S, and T, and those are your line inputs. Okay, then our outputs to the motor are going to be defined as U, V, and W. Okay, and those are just going to be T1, T2, and T3. That's just how they label these on these devices. Get used to seeing it if you're wiring them up in the field. Those will be your input and output for your incoming power and power out to the motor. In addition to that, we do have brake options. We're not really talking brakes as a part of this lecture specifically, but we'll touch on it in future down the road with some other lectures, okay? So basically, straightforward amounts of information there, and if we check it out on the lab board, you can see the connections hooked up inside. I've just got line 1, line 2 hooked up, line 1, 120 volt coming in off of my breaker, line 2 coming in off of the breaker as well. They're both just tied through the breaker. Regular 120 volt power. Then our 3-phase motor is going to be hooked to U, V, and W, and that's just wired right into the motor leads coming out of the top of the motor. Okay, so one thing we do want to consider is if I am using a 120 volt source to power a 3-phase motor, my consumption is going to be significant, right? I still need to kind of derive that power from somewhere. Even though I'm emulating those 3 phases, I'm still using more power than I would for a 120 volt application. So my power is going to be a lot larger. In the case of this 1/10 horsepower device, I think this drive is rated at 1/2 horse. It pulls 9 amps on the 110 volt side. Okay, so we do have to consider that as well. So is it possible? Is it something we can do? Abso-damn-lutely. But we do have to pay for that somewhere, right? You get that same power in equals power out scenario. Cool. So we've got that kind of worked through. You might want to go through your wiring recommendations, some of your other terminal block stuff. And then this page is incredibly important. You will have this with almost every manufacturer. It might look a little bit different, but this is just going to go through the basic wiring information inside of this and how it is by factory defaults. Okay. So there's a couple things we'll go over, and then we'll fire this bad boy up. But it's showing us our digital inputs. Okay, most, if not all, VFDs will have some form of digital input section. This is where we can field wire in devices. Okay, and we're just going to show you a basic stop-start tonight, but understand that once we can turn this thing on and off remotely, and we're going to do it via the PLC tonight because it's already pre-wired for it, you have the ability to make this thing work in any number of situations, just like a motor. Okay, same kind of concept. We can control it remotely. We can control it through the PLC if we need to. Unfortunately, I don't have an analog output card on my PLC, so I can't control it that way, but we're going to use the potentiometer, which is a pretty common application in a lot of industrial settings, to use a potentiometer to adjust these speeds. Okay, so we'll go through a couple more of those in a second. We do have a jumper in here from factory. So this is set up, if we remember our motor control setups, a start-stop station. We have 1 and 11 that are jumpered, and that's just to act as a stop button. Okay, so when we go and mess with the digital inputs, we will bypass that, and we will run that on our own, but we'll just keep it running as a 3-wire, so it won't be much of a concern. Most of the actual control portions will be handled inside the programming of the VFD. We can change that. We can do a lot of different things. Okay, we're not going to go deep into it. We also have a relay on top of there. The relay is just going to be like the relay on our PLCs, or a relay that you would see in the field. Just has a common, a normally open, and a normally closed. Now we can program exactly when we want that relay to actuate. We have a lot of options depending on your make and model of your VFDs. If they have output relays, you'll have a number of ways you can set those off. If you want that to trigger on a fault, if you want that to trigger when it's running, you have different options that you can set via the programming. Okay, and then our digital inputs. Okay, we have our digital inputs down here along the bottom, and we can do some different features. We're just going to set up a basic start-stop with this thing so we can start it, stop it remotely, and adjust the speed remotely. Okay, you also, for different sensors and situations, you do have a sync or source switch. This is going to be how you make your adjustments for PNP or MPN. Okay, like our talk on sensors last week. Cool. That's the basics, right? That's the basic stuff. Let's jump over to the lab board. So if we have this thing installed, I'm going to kick it on. The very first thing we are going to want to do if we are taking a VFD, we are moving a VFD, is we are going to want to set this thing up. Now, I was messing with this last week, so what I'm going to do right off the bat is I am going to reset to factory defaults. Sometimes if you get too deep in the sauce, that might be a move. If you're installing one for the first time, some of them have a startup procedure where it's going to force you through prompts to get all of your information for your motor. But in this case, I'm just going to go ahead and do a factory reset. So I'm going to go back over to my quick start guide. And when I get down a little bit, it's going to walk me through the startup procedure. I'm going to kind of go through that in a short condensed version with you. It's going to walk us through how to do some of the different settings on here. Fantastic. Viewing and editing parameters. Now these drives are typically done through a really annoying interface where you have a bunch of letters and a bunch of numbers, and they're going to go through different menus, and you're going to be able to set variables inside of there that change how the drive runs. They usually have a default setting and a setting that you can change them to, and that's all broken out, and then there are tables, and you're going to see the table here in a second. So when you go through into these, make sure you do your startup and at least program a couple of these things we're going to show you at the beginning here. Okay, display group parameters, just going to be some display settings on there. I'll show you one of those in a minute too. And what we're really going to want to focus on when we first use one of these is our smart startup with basic program group parameters. Okay, this is where you're going to set your motor nameplate voltage, your motor nameplate frequency. If it's 50 or 60 hertz, if for America it's probably 60. If it's foreign equipment, it might be 50. Okay, and we're going to want to set your motor overload current on there too. This is where we can make those adjustments to the overloads. Okay, we can also set other things like minimum and maximum frequency, and then we'll get into the controls here in a second. But like I said, the first thing I want to do is reset this thing to defaults. And luckily in this little quick start guide, I have P041, and that is going to reset to default settings. So it says right there, resets all parameter values to factory defaults. I have an idle state and a reset default state. So let's hop in the menu, find P041, and let's set that to 1 to reset our defaults. Yeah, that's probably an important step if you're moving one from location to location. And then you can go through all of your other parameters. So I'm just going to hit select to bring up my menu. It's going to flash on that D over there, and I'm just going to want to change that to a P. I'll hit my return button over on the end, and I'm going to just up my way to P041. I'm going to hit enter. Its default value is 0. I'm going to set that to 1 to force a reset to defaults. Okay, now when I reset that to defaults, it's going to throw a fault. That fault says F048, and I got my fault light flashing on there. Now, luckily, since I do have my amazing manual, I can go through and see what that fault means exactly. And you might have a fault for a number of different reasons. We'll check it out in the fault code table. But this is one of our diagnostic utilities we can use to figure out exactly what's going on with this drive. So I'm just going to navigate down to fault codes and see what that F048 is. I have F48 down here, and all it really says is params defaulted, and it's just letting me know that the drive was commanded to write default values to the EEPROM, clear the fault cycle or power to the drive, and program as needed. Cool. So it's just giving me a fault, letting me know that the drive has been reset to default, which is important. Okay, so I'm just going to hit stop to go ahead and clear that fault. I've accepted that that fault has happened, and now the drive is ready to roll. So in its factory state, with this drive and many others that may have a screen on top, you may have one that has a screen and user controls on it. You may not, but this one has a potentiometer built into it, so I can adjust the speed of the drive. Remember, that's going to be using pulse width modulation to release different sine wave. We're changing the frequency we're giving to the motor. Okay, and we got that green start button. So let's just run this thing and let's check it out in default settings. Let's see if I can get it to go. Interesting. Let's see if I'm hooked up right. Hold on. Houston, we got a problem. Make sure all my wires are actually connected. Looks like I'm good. Oh no, have I angered my drive? Let's restart it. Sounds like my drive's angry. Well, hopefully we didn't mess up the drive here. When in doubt, restart it. Let's try it again. Oh, we have angered the drive. The drive is mad right now. Well, let's try it again. Let's make sure we've reset to our factory settings. Well, it's going to be a short lab section if the drive doesn't want to cooperate. Cool, we got our F48 saying we reset to factory settings. Fantastic. Ah, I see what my problem was. See what my problem was. I removed a jumper for last class and I didn't put it back. Let's go back. This is what the problem was. This is cute. Cute. So on side of here, I'm supposed to have a jumper between 1 and 11. Let's put that back in. Without that jumper, that's acting as like our stop button. So without that jumper in there, that drive is not going to do anything. Oh man, caught me slipping already. Cool. We've resolved our jumper related issue. Let's see if we can get this thing to run. I went ahead and tossed that jumper back in. It's just that yellow wire right there. Let's see if we can get it to go. Cool. Now we're in business. Troubleshooting 101. Make sure if you reset to defaults factory settings that you actually reset everything to the factory settings. I took the jumper out, so now we have that in place. We're good. So all we're displaying on the drive itself is going to be that frequency we are running at. So as we make adjustments to our potentiometer, we are changing the frequency out of the motor, and we can see that it is reflected in how fast that motor will actually spin. So we can see exactly what we're doing. If we want to increase that speed, we can go ahead and do it right via the potentiometer on the front of the drive. We can increase that as high as we want to, up to 60, and you can see that ramp time inside of it too. Now our ramp setting is going to affect how long it takes to start or stop. So to go to full 60 hertz or whatever your setting is, you can make adjustments to that ramp setting via the programming. Okay, we're just going to go and find exactly what that is. Now the beautiful thing about these is we don't need to worry about our forward and reverse orientation. We have a forward reverse button and an indicator light up top, so we can just make changes via the programming. So when we start it back up, our ramp time is how long we are going to take to get up to that 60 hertz speed. Easily adjustable too. Okay, so over in our program, we could always go in and make adjustments to our ramp settings. And this is going to be the one they're talking about in your, do I have an easy one? Yeah, acceleration time and deceleration time. In these settings right here, we can change how long we want it to take. Default is going to be 10 seconds to get up to speed, but we can always change that to a different value if we need to, depending on our application and what exactly we have going on. Okay, cool. So that's the basics, right? We got this thing started up. What we really should have done first, I'm not super concerned about it in this scenario, is set exactly what our motor's parameters were. So that would be a pretty key step for you, is to go in and set PO31, PO32 for the hertz, and PO33 for the overload current. But seeing as how these two are basically made for each other, I'm not too worried about it in this situation. But definitely when you start one up, it's something you're going to want to go in and do. Set your voltage, set your frequency, and set your overload currents. Those ones right off the nameplate. Cool. Let's check the next thing we want to mess with. So we don't necessarily want the user to have to go in every time and start this thing from the drive itself. This might be located inside of a control enclosure. This might be located remotely. So what we need to do, or what we want to do, is give them ability to start and stop and control that speed remotely. So let's take a look at the I/O. Okay, the I/O is going to be listed right up here on the top, and we can wire it just like it says on here. Okay, we have a stop button on digital input 1. We have a start button on digital input 2. Now these can be adjusted and changed within the programming. Okay, and all of those different buttons are going to be run through a 24 volt DC common. Okay, so if that common is sent over and put on a start, it's going to start the motor, and if we break that stop button 24 to over to 1, we will stop the motor. Okay, pretty straightforward. That jumper is acting as it right now, but we're going to change that via the programming. Cool. So that's how we operate all those. Now we're also going to put in a potentiometer. Now we did a little bit of talk on this in our lesson on potentiometers, but what we're going to have is a common, a positive 10 volts, and then for that wiper terminal, that third terminal on the potentiometer, let's see if we can zoom that in. It'll look just like it did on our, see if I can get over to it. It'll look just like it did on our video we were watching. Okay, that wiper is going to run along that resistive material, and it's just going to give us an output somewhere between 0 and 10 volts, and that's going to tell the motor how fast it needs to go. Okay, based on where we have that volume knob, that potentiometer set to. Fantastic. But how do we get that to work? Well, let's see if we can figure it out. So the very first thing we need to do is wire this thing. We need that 24 volt DC sent over, and we're going to send it over to the PLC, and we're going to wire in that stop and start button, and then we'll come back and take a look at these other ones. Let's jump to the lab board. So what I did over here is I ran a couple different things. I've got a breakout board up on the top, and it has a common on this bottom terminal, and that's run to an expansion board on the PLC. Okay, so that orange wire is jumped between all the commons on the PLC, so I can pick up different voltage, voltage from a different source, and I can run that through the switches or the relays built into that expansion board to do different things. Okay, so we're going to use a couple of those and a 24 volt DC common off of the VFD, okay, to do some remote switching. So I've got that common run through. It's run to this green wire here. Fantastic. In addition to that, I've got the potentiometer broken out into black, red, and white, and we're going to hook those up to the terminals that are associated with the potentiometer on the VFD so we can do some remote adjustments to the speed of the motor. Okay, so let's hook those up real quick. So what we're going to do for this portion of it is we are going to remove that factory jumper that's acting as basically a normally closed stop. We're going to remove that factory jumper. I'm going to try to remember to put it back in so we don't have to troubleshoot at the beginning of another one. And I'm going to wire this business in. Okay, so let's take a look at the manual one more time. I'm going to want my common going to terminal 11. My stop button going to terminal 1, and my start button going to terminal 2. Easy peasy. So green is my common, so I'm going to jump that over to the 11 terminal on the relay. And then I'm going to take these pre-wired outlets, or these pre-wired wires I took off of the expansion board. Remember, that orange wire is the common off of the VFD, that 24 volt common, and I'm just basically going to have Y1 and Y2. I'm going to have Y1 act as my stop button, so I'll put that in terminal 1. And I will have Y2 as my stop button, so I'll put that in terminal 2. We'll just go ahead and wire that in. Now we need to wire in our potentiometer. Let's take a look at that one more time. Okay, potentiometer is going to go between 12, 13, and 14. 12, 13, and 14. Each side of that potentiometer will be between 12 and 14, and my wiper is going to be on 13. All right, easy enough. Let's do it. So I think based off this, my wiper is red. I should have black as the low, wiper red, and white for the other side of the pot. So I'm going to go ahead and stick those in. Got like a rogue piece of wire in here. That's not really a good idea. That out of there. Should probably stop stripping wires over the variable frequency drive. So we'll go ahead and wire those in. So we've wired in the potentiometer, a DC common, and basically 2 switch legs off the PLC that we can program to run however we want it to run. Cool. We're going to need to change some parameters because at default values, nothing's going to happen when I push it. It's still going to want to run off of our board up top, okay? So we need to make some changes before we're going to get anything to work. And in fact, as we saw at the beginning, once I've removed that jumper, I can't even start the motor anymore until I have fixed the situation. So let's first go in and take a look at the parameters that I need to change. Okay, up top it's just giving me a little bit warning of what terminal 1 is doing. Terminal 1 and 11 were that wire that's inserted inside of there, and I'm just going to change this to a 3-wire control. So we're going to go back down to our informational note down here at the bottom. In our diagrams, I am going to go to my start source. Okay, how do I want to start this motor? By default, it's going to be the keypad. Okay, but what I want in this scenario is just a 3-wire, kind of a start-stop station like we've built in the past. So I'm going to navigate to P036, and I'm going to set that to 1 for 3-wire. Let's check that out. So we will hop back over. Let's get into our P category. Looks good. I will enter. I will head to P036. It should be on 0 for the keypad as default, and I'm going to change that to a 1 so that way we can operate on 3-wire. Fantastic. Got that part down. Should be good. So now when I push the start button or I actuate terminal 1, or I was terminal 2, sorry. I think it was terminal 2, right? When I actuate terminal 2, I should get a start, and when I break terminal 1, I will get a stop. Fantastic. It's going good so far. Now I need to change my frequency setting. So I'm going to go down to my parameters again. Can be a lot of back and forth in this when you're playing with them. And I'm going to look at my speed reference. Speed reference is where it is getting its commanded frequency. So I want that to be a 0 to 10 volt. Okay, 0 to 10 volt input, just like we saw in the wiring diagram. So I'm going to go to P038, and I'm going to set that to 0 to 10 volt, which is a 2. Let's do it. Let's go back to select. Let's go to P. We love it. Let's go to 3.8. Awesome. Currently it's set to keypad, and I'm going to do 0 to 10 volt, just like in the wiring diagram. I'm going to set that to 2. Now, if I want to double check that I've got this set up right, different manufacturers have different ways of doing this, but we do have a awesome setting in display group, our commanded frequency. So we can go to D002, and we can see the commanded frequency to make sure that we got our speed pot set up correctly. So let's do that. Let's go into display group 2. Let's hit enter, and let's make sure our speed pot is working correctly. When I go up, we are getting our commanded frequency up. When I go down, we are getting it down. If you do have a display group like this, it's a good way to check your potentiometer, make sure you wired it correctly. If you put the wiper in the wrong location, or if you flipped your terminals, you might get the opposite effect. As I turn it up, my frequency would be going down, or different things would be happening. So before you start your drive, it's always a good idea to make sure, if you've got some kind of display group like this, that you have wired that potentiometer correctly. In this case, it's looking great, so I have a good feeling about that. So let's escape out of there. I like it. We'll go all the way back, and then its actual frequency is displayed on there, which is 0 presently. Now, what we need to do is get this thing programmed to run these buttons. Since I have everything hooked up through the PLC, I'm just going to go ahead and write a really basic program. But understand that you could make this as complex as you wanted to. I'm going to grab an input, and I'm going to throw it in here, and it's just going to be input 3. That's my red normally open push button. Now I want that to act as a normally closed push button, so I'm going to insert it as a break instruction. Okay, an examine if open or break instruction. I'm going to throw that in there, and I'm just going to run that over to the terminal I associated with the stop button, which is Y1. Since I'm running an expansion board, it will be Y this time. So I'll just run that right over to Y1. Now for my start button, I'm just going to put in input 1. That's my green normally open push button, and I'm going to install that as a make instruction. Okay, so we'll take that, we will just drag that right over to Y02, because Y02 is the one we've hooked to our start button. Cool. Once we've got that in, let's go ahead and link to the PLR. I'm going to connect, and I'm going to write this really super high-end program over. Old data in the module will be lost. That's absolutely fine. We don't really care. Give it a second to write. Awesome. And I'm just going to run this program remotely. I don't want to read the program from the module, because all that's going to do is show us what's on there currently. Since we just loaded something, it doesn't really matter too much. Let's hop over to lab board and see if we got this right. So if we push this green button, we should get a start. Fantastic. We've got the motor started. It is running. And since we have programmed that red button as a stop, when we push it, we should be able to stop. We should get control via the potentiometer now, so we can fine tune that from a remote location and dial in exactly where the operator wants that motor spinning. Okay, so that is our remote potentiometer, remote start stop station. Really nice. When we push stop, we should get a spool down and have that bad boy stop. So that is just the basics of your input outputs on this PLR. That's basically it. Okay. Anything else that you need to kind of note as you go through? There's a ton of settings in here. There's a ton of variability in here. We can change a lot of things to fine tune this motor and this setup and this equation to fit the parameters of our particular installation. But just having an understanding of the basic I/O, how to program this, how to get into the menus and find your settings is a good skill to have in your futures. So hopefully you picked up a little bit of something from that lecture, folks. And without further ado, I think it's time we probably call it a night.